All right, let's continue the DeMorgan's theorems. We are going to introduce two of them. They are very, very useful, and we can simplify our logic circuits. So first one, DeMorgan's first theorem. Okay, it's a very long sentence. Let's use a Boolean expression to describe it. It will be much easier. So we have two variables, right? Two variables timed together, and we have an overall bar. Okay, the bar means inversion, not. So we have a long bar or overall bar after x times y. Okay, the long bar. This one equals not the first one, not the second variable, and the sum together. Okay, so this is the first theorem. As long as we see an overall bar across multiple variables product together, times together, so we can apply this. So how to remember this? I show you my trick how to remember. We need to borrow a scissors. Okay, cut this. Okay, we have a very long bar, just cut it. Then the big bar, long bar come to small one and on top of each variables. And we swap the operation. This operation was AND, swap AND to OR. Okay, two steps, we cut it and swap the operation to opposite one. If this is plus, it will be times. Is times, it will be plus. Okay, easy to remember. So this is DeMorgan's first theorem. How to think about is correct or not? As I mentioned, to verify it's correct or not, we just use truth table. If truth table are all the same, which means this is correct, right? So two variables, just list all the possibilities for the inputs. Output, if this one is same as this one, okay, in terms of the values, and this equation will be valid, and you can test it. Okay, this is my answer. You can test if they are all correct or not. Okay, so let's do one. So this one, x times y means 0 times 0 will be 0. 0 not again will be 1. Okay, so this is correct. How about this one? Not 0 will be 1. Not y will be 1. So 1 plus 1 equals 1, which means this part is correct. Okay, you can do your own test. Okay, and so this is from truth table. And how about the circuit? As we mentioned, we have three of them: Boolean expression, truth table. How about the circuit? Circuit, how do we represent them? So not x times y. Actually, it is NAND gate. Okay, try to remember last week. NAND gate operation, we AND first, then we invert it. So actually, this particular Boolean expression means a NAND gate. Okay, and this one is something new, right? We don't give a name last week. Actually, it's called the negative OR gate. We do negative first, then we OR together. So which means, so say not one first, not another one, and then we OR together. So basically, this Boolean expression can be represented by this circuit. All right, so they are the same thing. So we can draw our circuit diagram using this one or using this one. Again, how to remember? Okay, I give you another trick. Bubble, okay, bubble from outside, from output. We push the bubble into the input. and bubble disappeared and go to input, and we swap the AND gate to OR gate. Okay. We push bubble from output to input and swap the logic gate from AND to OR gate. Basically, it's the same thing as scissors. Right? We cut scissors, and the scissors come up into each variable. All right. So it's the way how I remember. Okay, you can remember in your way. Okay, this is the first theorem to simplify our Boolean expression by more small parts. Second one will be very similar as the first one, like this. Okay, we overall bar on a product or times together. This one is sum together. Okay, same thing. Use a scissors to cut this long bar and just change it to small bar on top of each variables and swap the operation. It's a swap from OR gate to AND gate. Okay, or same way. How do we remember? Just use scissors. And this one is same. You can test by using the truth table. Okay, you can do it at home. You test they are same or not. Okay, I test they are the same. Okay. For circuit again, same thing. We push bubble from output to input. Okay, this bubble go to the inputs and change the gate from OR gate to AND gate. So this one is called the NOR gate. We already introduced last week. It's a NOR gate. Also, we mentioned last week, NOR gate and NAND gate, we all call them universal gate. Okay, we have some special features about universal gates. We can use only single type of gate to do any logic functions. Okay. All right, any questions? Okay, so good. We finished introduction about all the theories, rules, laws. Okay, that's all. Okay, that's all the rules and laws. Okay, that's good. And we are going to use this one in our lab 1 second part. We are going to test they are good, correct or not, using some DeMorgan's theorems. All right. Yes, this matrix. Break the bar and swap the sign. Okay. Let's do some practice. Okay. Again, it's not harder. It just need time to get used to it. Okay. Because it's we never met this before. Just give you some time to digest the concept. All right. So let's do the first one together. Okay, this one seems interesting. So we have many bars, right? So what do we do for the first step? We break the largest one. Okay, we start from largest one. So we can regard this part as a whole thing. Okay, this one is another thing. So one variable plus another variable with a overall bigger bar. It's a cut it. Okay, we cut here. Then we swap the operation from OR gate to AND gate. Okay, so let's do together. So in this case, we break here. Okay, then we have A plus B a bar. This is the initial bar. Then we have a new bar come here, and we change operation from AND OR to AND. Then we have double bar here. Okay, can you follow? Actually, we regard this one as a overall variable, and then we have this bar. then we have and this bar cut, and we have additional bar, so double bar. So rule number 9, double bar, invert again, we'll go to the back initial value. So in this case, this will be A plus D times C. Okay. Then we can stop here. So this will be correct. And also, if you wish, you can break the bracket, and this one will be also correct. Okay. Then we finish this question. Any questions? Okay, if no questions, let's do the second one. Second one, give you 1 minute. You do it by yourself. Okay, just again, we need more practice. Nothing harder, just need some more time, more practice. And second one, I'll give you a hint. We'll break this one first. Okay. All right. 1 minute, you can do your own practice. Grab a pen and you can do it by yourself. Okay. Some questions? I heard something. Some student asked some question. Okay. Benjamin, is the first version better because it uses less case? Yes, the first one is better. Yes, as we mentioned just now. Yes, first one is better. We only need 2 gates, right? This one and 1 OR gate and 1 AND gate. This one we need 2 AND gate and 1 OR gate. Yeah, you're right. Yeah, both of them are correct. First one, from circuit point of view, it's better. All right, just maybe another half a minute and try to finish question B. So more practice. All right, let's do together. We regard this bracket as a whole variable. Then we break the long bar. Then we have a bar like this, and C, D, a bar. All right, it's correct or not? Okay, I think it's correct. And how about this part? Then we break this part and break this part. Okay, just some practice because we have a long bar on more than 1 variables, 2 variables. We need to break it. Okay, first this part and break it. We have 1 bar, another bar on A, and all gate come to AND gate, and we have a bar here. Okay, how about this part? C bar plus D bar, and here. Right? Can you follow? Now double bar A will be A times B C D. Okay. So this one is correct. Also, you can break the bracket out. Should be also correct. So this one will be also okay. All right, that's the some practice. Just try to imagine use a scissors to cut the long bar. Then we can simplify this Boolean expression from this very complex one to this simple one. Okay, we have a total bigger bar. All right, any questions?